India's defense exports notched a strategic victory when Morocco confirmed the induction of a made-in-India armored vehicle, the Wheeled Armoured Platform 8x8. The North African nation is set to field nearly 400 units of this platform, jointly developed by DRDO and Tata. Although the contract may look modest on paper, its significance runs deeper. A foreign military has officially validated an Indian-designed combat vehicle. But as this export milestone unfolds, many in defense circles are quietly asking, why hasn't India fully adopted its own battlefield-ready combat vehicle? The Wheeled Armoured Platform was conceived as India's next-generation replacement for the Soviet-era BMP-2. WhAP is an armoured vehicle built by Tata Advanced Systems and DRDO, weighing 20 to 27 tons. It's designed for jobs like carrying troops, fighting, scouting, or commanding operations. It uses a strong 600 HP Cummins diesel engine with automatic gears and special suspension, reaching 100 km per hour on roads and 10 km per hour in water with hydrojets for river crossings. Lighter versions under 24.5 tons can float, and all 8 wheels keep working even if damaged, making it great for rough places like Ladakh. Its armor stops bullets, and extra panels can be added to protect against explosives. It also has night vision for dark missions. The vehicle holds 12 soldiers and can carry different weapons like a remote-controlled 7.62mm machine gun, a 30mm cannon, anti-tank missiles, grenade launchers, or systems to stop drones. Technically, WhAP boasts a monocoque hull with STANAG-level mine protection, an independent hydropneumatic suspension for cross-country speed, and a fully digital architecture ready for integrated battlefield management systems. The turreted version, often equipped with a Kongsberg MCT-30 remote weapon station, delivers stabilized fire with day-night optics and automated target tracking. Engineers designed the power-to-weight ratio around a Caterpillar 7-liter engine to ensure over 100 km per hour on sealed roads and swift maneuverability off-road. All of this aligns neatly with the Army's stated goals of networked mobility and survivability in hybrid warfare. It's been tested in tough high-altitude areas and performs well, helping India rely on its own defense tech. Yet after the initial double-digits order, no bulk procurement followed. Instead, the Army launched parallel evaluations of an off-the-shelf competitor, the US-made Stryker infantry combat vehicle. Weighing around 19 tons, Stryker, powered by a 350 HP engine, reaches 100 km per hour on roads but lacks amphibious features. It offers modular armor up to STANAG-level 4 and weapons like 30mm cannons or missiles, carrying 9 troops. In Indian Army trials, especially high-altitude tests in Ladakh, the Stryker underperformed with power shortages, near breakdowns on steep terrain, and no water crossing ability, key for India's borders. The WhAP with 600 HP aced these in deserts, mountains, and mud, proving better mobility, protection, and cost. This led to Stryker's rejection, favoring indigenous self-reliance despite US lobbying for imports. However, General Dynamics, its makers, plans to demonstrate a re-engined model with enhanced amphibious capabilities for the Indian Army in late 2025, following the baseline version's rejection in July. So, the question remains, why hasn't there been large-scale adoption of WhAPs? Even though WhAP has demonstrated strong performance in trials, a full-scale purchase remains on hold until the future infantry combat vehicle doctrine is finalized in 2025. Committing to an entire fleet today risks locking procurement into a design that may not meet evolving requirements for battlefield networking, crew protection, or firepower. With capital funding spread across multiple modernization efforts, the service prefers smaller initial orders. This phased approach lets frontline units operate WhAP in real conditions, share detailed feedback with Tata and DRDO, and guide targeted upgrades before any larger buy. It also keeps budgetary risks in check and preserves flexibility to adjust choices as doctrine and technology mature. Logistics and training factors further explain the delay. Maintenance depots and technical teams are currently geared towards Soviet-era BMP-2s and T-72s, right down to spare parts stockpiles, workshop tooling, and repair manuals. Introducing WhAP's new engine, transmission, armor modules, and fully digital architecture would require fresh supply chains, specialized tools, and extensive instruction for crews and technicians. Without a fully developed overhaul ecosystem, adding the platform could stretch repair cycles, lower vehicle availability, and push up life cycle costs. Until WhAP consistently hits strict reliability, maintainability, and availability benchmarks in extended service trials, and until depots, training schools, and logistics networks are ready, bulk induction is likely to wait for both doctrinal alignment and support infrastructure to catch up.